Okay, here we go. We'll try it from this angle for the next couple of problems. Uh, okay, so 5.2. So the next one, 5.273. Let's take a look. 5.273. Okay, so that's tan x over 1 plus cosine x plus sine x over 1 minus cosine x equals cotangent x plus secant x cosecant x. Okay. Well, okay. Um, Okay, so definitely, I think that trig identities like this, where there's like a lot of stuff going on, they look nastier than they end up being in my experience. But I could be wrong about this one. But I feel like when there's a lot going on, there's a lot for you to be able to manipulate. So there's a tons of ways that you could start this problem. I'm inclined. Well, I was going to say I'm inclined to try to add these two fractions together to see where that leads me. Now that's going to require me to multiply here by 1 minus cosine and here by 1 plus cosine to get a common denominator. But that actually I think will end up being nice because then we just get 1 minus cosine squared, right? Which will turn into sine squared. So let's do it. So here I'm going to multiply by. So I'm going to start on the left-hand side again. Here I'm going to multiply by 1 minus cosine. And here I'm going to multiply by 1 plus cosine to get the common denominator. Okay? Let's see what that gives us. Not to, well, yeah, okay, so I'm going to go ahead and distribute that. So I'm going to get tangent minus tangent cosine over, now here I'm going to get 1 plus cosine minus cosine, so those cancel, and then minus cosine squared. Here I'm going to get sine plus sine cosine over same thing as before, 1 minus cosine squared. Maybe, well, okay, so let's see what we get. Now we have tangent x minus, now tangent is sine over cosine, right? So I'm really thinking of this like sine over cosine, in which case the cosines are going to cancel and just leave me with sine x. And in fact, I'm going to change the 1 minus cosine x into the sine squared x now. It's just nicer to have a denominator that has a single term instead of 2 terms, right? If you can make it 1 term instead of 2, I think that's generally speaking like that's a win, Okay, so, and then here, well, I don't really know. Maybe it would have been better not to have distributed that sign in the first place, but we'll see. Okay, anyway, but I have the same denominator. I could add these. Oh, that is nice, actually, right? Because now that sign and that sign cancel when I go to add these up. Oh, yeah. Okay, so that's good. Okay, so bringing this back over here. So now I'm going to have, when I put it all together, I have tangent x plus sine x cosine x over sine squared x. Somehow I've got to get this thing to look like cotangent x plus secant x cosecant x. Huh. I might, I might like abandon ship here, start working on the right-hand side, see if I can get it to look like this. One thing that does occur to me is that I could think of tangent again as sine over cosine, factor out a sine, and cancel a sine in the denominator there. Then I'd be left with a 1 over cosine, which is the same as secant. So I'd have secant x plus cosine x over sine x. I feel like that gets me a little closer. Maybe I'll do that. So here's what I was thinking. Now factor out the sine x. Well, and I'm just going to go ahead and cancel. So sine x cancels there, and one of those. So now I've got a 1. Now I've got a 1 over cosine x, which is the same as secant, right? So I've got secant x plus cosine x over sine x, which looks a little nicer. Can I get it to look like that? I don't know, man. Huh. Oh, yes. Oh, yeah. Yeah, we've got it. We've got it now. We've got to switch these around and split the denominator. So I'm going to switch them, cosine x, and then I'm going to put the secant x over here, and I'm going to go ahead and split that denominator, right? Sine x, sine x. I think this does the trick. Oh yeah, there it is, right? Cosine over sine is the same as cotangent. One over sine is cosecant. So here we have a secant and a cosecant, right? So secant x and a cosecant x. And there it is, right? There's the right-hand side. So we did it. Again, oh man, there's probably a bunch of ways to do that one. All right.